In my last video, I gave 2 lines of empirical evidence and 1 philosophical argument against physicalism as part of my argument for the existence of God. In today's video, I want to hone in on another quick philosophical argument against physicalism. The argument was developed by philosopher James Ross in his paper Immaterial Aspects of Thought, and was later refined by Catholic philosopher Edward Fesser. The argument has a simple form which runs as follows. Premise 1. Formal thinking is determinate. Premise 2. Physical states are indeterminate. Therefore, those kinds of thoughts cannot be physical states, and therefore physicalism is false. Premise 1 states that formal thinking is determinate. To examine this premise, let's start by first clarifying definitions. Formal thinking refers to thoughts about logical and mathematical functions like adding, subtracting, squaring, modus ponens, etc. We should understand determinacy in light of the following definition. X is determinate if and only if X can only be thought of at the exclusion of all other incompossible forms. Now, with the terms of the premise clarified, why think that formal thinking is determinate? Well, consider 2 examples, squaring and modus ponens. When we think of squaring, we are thinking of the form n times n equals n squared, and not any other form. So this thinking is determinate. If it were not, then we should not expect to be able to get the square of a number when we actually square a number. Next, consider the thought process. Jack is a man, all men are mortal, therefore Jack is mortal. We can change Jack to any name and the result will be the same, so long as we don't change the form. That means we mentally grasp that the form is determinate. That's the only way it can be. So premise 1 is true. Now some might object that when we think formally, we only approximate the logical/mathematical concepts. However, James Ross identifies 4 problems that plague this objection. First, it's just extremely counterintuitive to assert that whenever we've tried to add, square a number, or draw a modus ponens inference, we have actually been mistaken the entire time and have not really done so at all. Second, if we never really add, apply modus ponens, square numbers, etc., then it becomes inexplicable as to how we've acquired so much knowledge in the fields of logic and mathematics. The natural sciences also presuppose both, so how is it that we've gained so much insight when no one ever successfully performs logical and mathematical operations? Third, if we never really apply modus ponens or any other valid argumentative form, but only approximate them, none of our arguments are ever actually logically valid. And if none of our arguments are logically valid, no argument is successful, which seems to undermine all of analytic philosophy. Finally, asserting that we never really add, square, perform modus ponens, etc., is self-defeating, since to coherently deny that we ever really do these things presupposes we have some grasp about what it is to be able to do them. These problems are absolutely devastating, so we can safely dismiss the objection. With that addressed, I think we've made a pretty strong case that formal thinking is determinate. So let's move on to premise 2. Premise 2 states that physical states are indeterminate. Again, let's start by getting our definition straight. A state is physical if it can be studied by the natural sciences or reduced to those studied by the natural sciences. Keeping this in mind, why believe that physical states are indeterminate? I think reading aquinas.wordpress.com gives a powerful example to show why physical states are indeterminate. Quote, "Suppose I was playing pool and I pocket the first ball. That's the first set of physical changes that takes place on the table. But what does this mean? Did I subtract 1 ball from the table, or did I add 1 ball to the pocket? Or maybe what I did was to subtract 1 striped ball, if it was striped, from the other striped balls, etc. That's not even all I can come up with to describe the physical changes. The fact of the matter is that there are many other formal descriptions, other than the ones already mentioned, that are realized in the physical changes taking place on the table, and all of them incompossible to each other. Therefore, physical states are indeterminate. There is nothing about the physical state themselves, even if you knew atom for atom what each state was at any given moment, that would tell you what form is being realized, as if it was realizing many incompossible forms." End quote. This point has been driven home by numerous philosophers, including Saul Kripke, who illustrates the point through what he calls the rule-following paradox. The rule-following paradox is based off the work of Ludwig Wittgenstein and was formalized by Saul Kripke in his book Wittgenstein on Rules in Private Language. The rule-following paradox shows us that any course of action can be made to be in accordance with an infinite number of normative rules. Kripke gives us a mathematical example to illustrate the reasoning that leads to this conclusion. Suppose that you've never added numbers greater than 57 before. Further suppose that you are asked to perform the computation 68 plus 7. Our natural inclination is that you will apply the addition function as you have before and calculate that the correct answer is 75. But now imagine that a bizarre skeptic comes along and argues 1. That there is no fact about your past usage of the addition function that determines 75 as the right answer, and 2. That nothing justifies you in giving this answer rather than another. After all, the skeptic reasons, you have never added numbers 57 or greater before. It is perfectly consistent with your previous usage of plus that you actually meant the quus function, defined as follows. X quus y equals x plus y for when x and y are both less than 57, but 5 for when x is greater than 57 or when y is greater than 57. Thus, under the quus function, if either of the two numbers added is 57 or greater, then the sum is 5. The skeptic argues that there is no fact about your past physical behavior that determines that you ought answer 75 rather than 5, as every prior addition is compatible with the quus function instead of the plus function, as you've never added numbers greater than 57. So, the fact of the matter about which normative rule is being followed cannot be explained in terms of physical behavior. The only way out of this paradox is to say something like, well, I just intended to follow the rules of addition. But that's an omission that the normativity of intentional states cannot be reduced down to the physical states of affairs, and thus intentionality cannot exist in a purely physical system. The point of the thought experiment is this. Any set of physical evidence you give for why you meant addition could just as easily be used to argue that you meant quaddition. In other words, the physical states of affairs are indeterminate. Philosopher Nelson Goodman offers a similar thought experiment that demonstrates the indeterminacy of the physical. Goodman's example of the color grue is usually appealed to in debates about induction, but for the context of this argument, it can be used to strengthen the case that physical states are indeterminate. Grue is a predicate which applies to anything before some time t, just in case it is green, and to every other thing just in case it is blue. We run into the same problem Kripke discussed. As Edward Fesser points out, quote, "For just as all the evidence is compatible with the superstition that I have always meant quus when using plus, so too is it compatible with the superstition that I have always meant grue when using green. These three considerations give strong support to the thesis that the physical is indeterminate, and from premises 1 and 2 it follows inescapably that formal thinking is not physical, and therefore physicalism about the mind is false."